Hi everyone! As our isotope laser is broken, we have a lot of time this time in the field to conduct more plant physiological measurements, and one that is really widespread, has been around for decades, and that we're also doing a lot right now is plant water potential. So in this video I'll explain to you what that is, how we measure it, and also what it can tell us about plant water status.
Basically, water potential drives the movement of water through plants. It is an important indicator for plant water stress and provides insights into a plant's water use strategy. At our field site in the Costa Rican dry forest, we are taking measurements of different species over a period of 2.5 months during the transition from dry to rainy season. With this, we want to find out more about their water use strategies, their access to deep soil water, and how stressed they are at times when water in the surface soil is limited.
Water potential is a measure for the potential energy of water. Distilled water under atmospheric pressure has a defined value of 0, and all waters in an ecosystem usually have values below 0. And those values depend on solute concentration, gravity, pressure, and also the so-called metric effect, which is factors like capillary forces. Differences between water potential determine where water moves in an ecosystem. And water always moves from the higher to the lower, or less negative to the more negative water potential. Sounds complicated? Let's look at the example of tree water uptake. So for a tree to transport water from the soils up to the leaves and out to the atmosphere, the water potential has to be increasingly negative along the whole transport pathway. So now, how do we measure this? The value that we measure is dependent on the water supply in soils, influenced by the texture, the temperature, and also the plant's root system. It's also influenced by plant regulation, so mainly stomatal opening or closing, but also permanent adaptations like waxy or hairy leaves or sunken stomata. And then the atmospheric demand also impacts it, which is determined by solar radiation, air temperature, humidity, and wind. So essentially, the plant water potential that we measure reflects a plant's water status as well as atmospheric conditions. This is the device we use to measure plant water potential. It's a Schalander pressure chamber, also called Schalander bomb, but we avoid that term if we go across borders. Its central unit is this pressure chamber inside here, where you can enclose a leaf. You can use these regulators to increase the pressure inside the chamber, and then you can see the pressure inside the chamber here. And we have some magnifying glasses so that we can see better. And the pressure comes from this bottle of compressed air that is connected to it. And once we're ready to measure, we cut off a piece of branch and we place it inside this lid, and then we can place the leaves inside the pressure chamber so that we can still see the cut surface from here. And we close it tightly, and then we're ready to increase the pressure. And now we're increasing the pressure until water comes out from the cut surface, and this overpressure within the chamber then equals the water potential that was present in the branch or in the leaf at the time when we cut the branch. With this one, it's about 2.2 megapascal. When it's bubbling like that, you already went a little bit too far, but it's quite hard to film this, to be honest. Also, this is one of our easiest species. There's other species that have latex or some other etheric oils that sometimes make it really hard to distinguish those from water. So yeah, I was experimenting with this a lot, and yeah, a day of water potential measurements is doing this 3 times per branch 2 to 3 individuals per species, and then 2 times or even 6 times a day. So you can imagine that this amounts to a lot of measurements in one day.